Alright, so I want to talk about the probability that the mean of 465 M&Ms is at least a given value, which I'm going to show you. And we're going to be doing this on a TI-84 using norm CDF. Alright, so let's get to it. Alright, shout outs to OP Asine for asking this question. It says M&M plain candies have a normally distributed weight with a mean of 0.865 grams and a standard deviation of 0.518 grams. If 465 M&M plain candies are randomly selected, find the probability that their mean weight is at least 0.8535 grams. Alright, so at least 0.8535 grams. Would anyone know how to solve this? Alright, so let's see how we can solve this. And we're trying to find the probability that the mean weight is at least some value. Okay, that's important to realize that we are talking about the mean. You need to understand something. We're talking about the mean weight of M&M candies. Now it says that M&M candies have a weight that is normally distributed. So we can actually say that we have a variable x which equals to the weight of M&Ms. Furthermore, x is normally distributed with the mean 0.8565, standard deviation 0.0518. So we have this information. So this describes what the random variable is and its distribution. So this is the distribution. Now we know something else, that x bar, that equals to the mean weight of 465 M&Ms. Now x bar is also normally distributed with the same mean, 8565. But now we use the standard error instead of the standard deviation, 0.0518 divided by square root of 465. Now that's going to drastically decrease the standard deviation, so we call it the standard error. At any rate, the dispersion is going to get really smaller. So if we draw a picture of what we're trying to find, we can put the mean in the middle, 0.8565, and it wants to find the probability of getting a mean weight that is at least 0.8535. Notice that 0.8535 is to the left of this, so I'm going to draw it over here, 0.8535. And it says at least, so I'm going to shade to the right? It says at least. So we know that this probability will be bigger than 0.5. But let's find it. The probability that x bar is greater than or equal to 0.8535. So how do we find that? That's equal to norm CDF. Let me zoom in a little bit. It's norm CDF, lower, upper, the mean of the sampling distribution, standard error of the sampling distribution of the mean. So this equals to norm CDF. The lower is going to be what? This one right here, which is 0.8535. The upper is 9999, just some big value. The mean of the sampling distribution of x bar is 0.8565. And for the standard error, it's right here. So we could just use that, 0.0518 divided by square root 465. Let's try it on a calculator. Second distribution, norm CDF, 0.8535, comma, bunch of nines, comma, 0.8565 is the mean, comma, 0.0518 divided by square root 465. We get approximately 0.8941. So that's the answer. That's it.